Hello, everyone. Let's take a look at the third question in the homework for this week. There's some questions about rationalizing the numerator, and next week we'll talk about why we need to rationalize the numerator. And here we're going to look at the algebra part. For example, the take number 1, for example, right? We're going to rationalize the numerator. So here we go. We got, we have a, let's see, what was the question? Okay. The question was 9 plus h. Okay, 9 plus h. So let's see, this is being shared. Okay, 9 plus h. I'm gonna clean this up. Okay, and here we're gonna do rationalizing the numerator by divided by h. Okay, rationalizing the numerator. When we rationalize the numerator, one of the technique we use when radical is present is that we're going to multiply the conjugate. Okay, the conjugate of the numerator. And here the numerator has a radical. Okay, so the conjugate of root minus 3 is root plus 3. Okay, plus 3. And so here we're going to multiply by 1. So this entire thing is equals to 1. So we just replace 1 by another form. And this form of selected that we selected will allow us to get rid of the radicals in the numerator. And now we're going to do numerator times numerator, denominator times denominator. So denominator multiply denominator. Wait. Okay. Denominator. Okay. Denominator, well, this denominator multiply this denominator. Make sure you have a parentheses inserted. And then we're going to multiply this numerator with the other numerator. And now we got a conjugate situation. Okay, we got a conjugate situation here, which is a minus b multiply a plus b, which equals to a squared minus b squared. You can see this formula is used very often. Okay, and of course our a is root 9 plus h, and the next step b is of course is 3, and then we keep the denominator. Okay, now the radical is in the denominator. On the numerator, we have the a squared with parentheses squared minus b squared, which is 3 squared. And then we reduce. Okay. And here this is going to be 9 plus h, and 3 squared is 9. Okay, so in this case, we were using this result, which is the square root of something, x or whatever, omega. Okay, so I'm going to use a different symbol. And then square. This equals to omega. However, right, the square root of omega squared is actually equal to the absolute value of omega. You may wonder why. Okay, I'm going to explain this in a minute after we're done with this question. Okay, so let's finish this question. 9 minus 9 equals to 0. So we have h left. And now we can reduce the h using principle number 1. So by this point, okay, and then we can remove that. We can also remove parentheses. Okay, so that algebra expression, rationalizing the numerator, is now down. Numerator, sorry about the typo. Okay, so now let's come back to this 2. What's the difference? Why? Why? We certainly have done this one plenty of times. So which is, another model of it is x, and of course here's x. And here we're going to put it back to x here. Why is this true? Why is this true? Well, what's the difference between this piece and the other piece? Right? What's the difference? If we treat them as a function, if we treat them as each as a function, we will notice that for the first one, okay, according to the order of operation, that we have x, and this x, after the input is given, we're going to do the square root of x. So this x has to be in the domain of square root of x. So after square root of x is found, and then we will be able to do the squares. We'll do the squares. That's the order of operation. Input, and take square root of the input, and then square, after the square root is found. So this requires x must be in the domain of square root of x, which has to be greater than or equal to 0. Okay, in the second one, however, you have x, right? And x is going to be, after x's input is given, we're going to do x squared. After x squared, we're going to take square root of x squared. Because any real number after it's being squared, then it's going to be non-negative, right? So this is always going to be greater than or equal to 0. Right, no matter what x is. So this x actually is all real numbers. Okay, it can be all real numbers. So let me show the. So this x over here is from negative infinity to positive infinity. Okay, you can see the difference in these two expressions are dramatically different. So when we use this expression by default, x is going to be greater than or equal to 0. When we use this expression without any specific, statement, then x can be any real number. So that's the major difference. And that difference determined that this piece is going to be equals to x, because x is always greater than or equal to 0. But in this piece, however, x has to be the absolute, the square root of x squared has to be absolute value of x. Okay, so this is very important to understand, because when you rationalize a numerator or denominator, when radicals involved, you often encounter this situation, and so you're going to apply this, this form. Okay, so let's see if we shall do another question here. This other question, we're going to work with, it would be, let's try this one, right? This one, it doesn't have an apparent square root. Okay, we are asked to rationalize the numerator. Actually, there's no radicals in the numerator. But if we take a closer look as we start working on it, we actually see we have 1 over t minus 1 over c times 1 plus t. Okay, let me see if I copied that question correctly. Okay, just make sure. Wait, hold on. Just to make sure. Oh, I should reverse the order. Minus 1 over t, okay? Sorry about that. Minus 1 over t. So minus 1 over t. 1 over t. Okay, so why this question showed up here and we're asked to rationalize the numerator? Well, let's move on with a few steps. Okay, here we have a 1 over t, we have a 1 over t. So what we could do is that we can factor out 1 over t, and then we'll have inside the parentheses, we will have 1 over root 1 over t, root of 1 over t minus 1. Okay, and then we would want to find the common denominator. And the common denominator is going to be, this is the common denominator inside the parentheses, right? So make the common denominator. So now what we get is that now we have the common denominator, right? And we're going to take the numerator, subtract the other one. So this is going to become 1 minus. Now we have radicals in the numerator. We could actually remove this parentheses, and we're going to work on the conjugate. The conjugate of the numerator is going to be 1 plus root of 1 plus t. And numerator, and because we're using principle number 1, so we just multiply by 1. The whole thing is 1. Anything times 1 stay the same. And we got our conjugates. Okay, so now let's look at our denominator times denominator. So t is going to multiply root 1 over 1 plus t. And there's another one. This one needs to be in parentheses. Okay, and this dot can be removed. And then on the top of 1 times, and this the conjugate, and we're going to apply that property one more time. Right, you can see that's very useful. And then we're going to have 1 squared. 1 squared is same as 1 minus square root of 1 plus t and squared. Okay, and we'll keep the denominator in its form of factored form. Okay, we'll keep the denominator in the factor form. Don't try to, expand it. Just leave it in this factor form. 1 factor, 2nd factor, 3rd factor. 1 squared is 1, right? And we get to use that piece again, right? We got to use that piece one more time. And that's there. Okay. So this is 1 plus t. 1 plus t. If I just write 1 plus t and I have already committed a mistake, okay, it needs to be in the parentheses. If you want to remove the parentheses, then you should have minus t. Okay, all right. So now 1 minus 1 is 0, we have a negative t, and t will be reduced. So we reduce the t is gone, so we have 1. So that's final, okay, the algebra part. I think these examples should be helpful, I hope. And try the other ones. If you have any questions, then please don't hesitate to reach out to me. Okay, thank you for watching.